I'm the technical manager of eLabtronics. We started a STEM Inventors Club called Stem Cell. You might have heard of Stem Cell. You probably know what STEM stands for: Science, Technology, Engineering, Maths. The SEL is Social Enterprise Learning. So STEM, Science, Technology, Engineering, Maths, are actually tools. Okay, we can learn about the tools, but it's like you're going to teach someone how to drive. What do? Take out the specifications of the car, you show the maps of the road, you tell them about how to do the things, but you never get into a car. Are they going to learn to drive? They actually need practically to do the things so that they can use it. So social enterprise learning is the object. So for example, we have a project that might be a problem for people. It might be climate change. Why have we got climate change? Because carbon goes out into the atmosphere. How can we reduce the carbon? Well, we might, for example, create clean energy. Clean energy, okay? Maybe wind power. If then we can create clean energy, can we create electricity? Can we create energy in the room? If we can actually create some electricity in the room, we might be able to then learn about how to create electricity and stick in the students and people's thinking on how it actually works. So we then describe and say, of course, you need wires for electricity. That's what conducts the electricity, but we need magnets. Even in a DC motor, there are magnets. Okay? If we make them go around, we might generate a little bit of electricity. So then we start making a plan. Okay? If we can generate a little bit, maybe we can measure it. We can measure electricity. Then what can we use? We use microchips, we use microcontrollers. We have a graphical language which we invented so that students can actually easily get started. Okay, so we go through the steps and then we can put it together. I'm going to show you a video. I've painted you a very broad picture of what we do, but I'm going to show you a video of what was on the news recently of some students actually using stem cell in a workshop, because I'm here basically to talk to parents and teachers mainly about seeing if they can actually start some stem cell inventors clubs at school and after school and on weekends.
A recent study's shown that most Aussie parents want their kids to learn more digital skills at school, like computer programming. They say knowing how technology works is really important to inspire the next generation of inventors and engineers. Amelia went to a classroom to find out more.
It's the class of the future.
Did you know that my brains are made out of rocks?
And these Year 7s are learning the tricks of the trade.
Okay, everyone, we're going to prove that many hands make light work. So concentrating. Yes, the light is starting. Very good. Excellent.
They're learning how to design, build and program these mini computers.
Every day, even just switching the lights on, you're using a microchip, and you can use thousands each day.
Our world is computerised, but there are worries kids aren't being taught enough digital skills, like computer programming. And that's something many want to change. A recent study showed the majority of Aussie parents want computer skills to be part of Australia's curriculum.
We need to be encouraging the next generation of inventors. So if we can get them to start early, in primary schools even, then their creativity has the opportunity to flourish and blossom.
These guys are big fans, and they reckon every kid should give it a go.
It's really fiddly and it's like fun to do stuff that you're not really used to doing.
It's really important in the coming future of technology as well, so I think it should be compulsory.
And in this room could be the world's next engineers, programmers or famous inventors.
There's lots of different types of sciences, and I've tried quite a few of them, and I think this one's my favourite.
Okay, and so you can see that the kids are actually very much engaged in what they're doing. We actually run a club so they can also help each other. The projects that we have normally run between an hour and a half to 2 hours. So it's perfect for an after-school club. They actually get to finish all the steps. They go through the problem, talk about the problem, about the ideas. Okay, what are their ideas for the solution? Then we come up with a plan on the board, actually draw a picture of the plan. How do we then follow a plan to do the design? We have a program that block diagram, basically with a controller, and where each of the connections go. Once they do that, the program then automatically generates a test program for the outputs. They then just take a USB cable, plug it in, and the outputs run. If they're connected correctly, they run. That tests the whole system. After that, then the graphical system actually comes up. They can take out the test program. They then do everything from the beginning, from scratch, and put it together and implement their plan to get it actually working, so that they can, for example, generate some electricity. You'll notice on this one, this isn't actually the project to generate electricity. This is the project for controlling the temperature. So we have a fan on this one to cool down a temperature sensor and a little light bulb here to warm up a temperature sensor. You'll notice as well that we have a 3D printed section, struts here to hold the components. We supply 3D printing information so that schools, even parents now have 3D printers. You can print it out yourself. You can modify it, you can change it, and then you can connect into the components so the 3D printing actually becomes useful. All right, how we actually run the clubs. Let me go back. How do we go back on this? Just close that one. Okay. I want to show you this one here, because this student came to our stem cell club that runs on weekends. He ended up actually going with his father and starting a club after school. In fact, he won the Inventors Competition at the Royal Show recently.
Hello and welcome, I am Heath. I have been attending stem cell for the last 6 months now, and I'm really loving it. I'm going to show you some of the things that I've been doing at stem cell.
One of the advanced stem cell classes I attended a few weeks ago, we were learning about binary digits, or bits. One of the projects we put together using a stem cell microprocessor was a binary counter. In class we only made a 4-bit counter, a nibble counter. At home a couple of days later, I put together an 8-bit counter using extra LEDs I had lying around. This made a byte counter.
One of the other things I've always loved is fiddling with Lego.
Over the years, my dad and I have collected lots of Lego. We have organised it into boxes and labelled them so we can always find the piece we need. To include a stem cell microprocessor into Lego projects, we have modified Lego bricks to include light-dependent resistors, LEDs, and servo motors, as well as connectors to allow us to control Lego motors with a stem cell board. A few months ago we started by using those modified bricks to build a train set with a working train crossing controlled by a microprocessor.
2 weeks ago at school, we had to bring 2 things that described who we are. I just decided to bring Lego and a computer. To join these 2 things together, I used a stem cell microprocessor to make a Lego line following robot.
My dad and I had a competition to see who could build the best line follower. The line followers incorporated 2 light-dependent resistors and an LED to follow a line. We took a bit of fine-tuning to the programming to get the robots to follow a white line on carpet. We also reprogrammed the robots to follow a black line on shiny floors. I took my line follower to school and presented it to the class. My teacher and classmates were very impressed. As a result of this, we may start up a stem cell club at school.
As you can see, I really enjoy making and modifying Lego bricks in stem cell. I can see myself doing this for a long time to come.
We have already started improving our Lego train set by including working boom gates. We intend to continue to expand the layout by installing more sensors to detect trains going the opposite direction and installing stem cell microprocessors into the trains themselves to control their movement. We'll keep you updated with our progress.
Okay, Heath's father ended up actually starting a stem cell club on Wednesday evenings for an hour and a half. His school let him use the facilities over there. Lots of schools are actually looking for STEM clubs anyway. And his son then ended up going to USA. He actually won the Inventors Competition at the Royal Adelaide show. We run an Inventors Competition. You might have seen Sparky the robot speaking and some others. And he ended up in the US, and he ended up in also the newspaper, and they've gone on to continue to run the robotics at Hallett Cove. We've had Kavia, who won $5,000 for her invention for a texting plant. She worked out how to connect to a phone so that plants can actually text you what they need. We've actually have a young student called Michael who's currently in our workshop area at TAFE SA. We're actually running workshops. The next workshop is actually at past or about to start probably in 10 minutes when I get back there. We also have a stand at stand number 20, Stem Cell Inventors Club, but we're particularly looking for schools or parents who would like to help to start a club at school, or teachers who would like to get into stem cell and use it as STEM curriculum, which is now required by the Education Department for primary schools as well as high schools. Okay, that's it. Thank you.